In terms of the overall technologies for reactive polymers, there are a large number of companies that not only make machines that are tailored for working with specific compositions and chemistries of reactive polymers. So the machine architecture, in addition to the material composition, are all interconnected in some ways. Stratasys 3D Systems, Envision Tech, Kudo 3D are examples of materials based on inkjet printing or stereolithography. Formlabs, FSL 3D, X1, VoxelJet are examples of variations of the vac polymerization technique as well as extension to binder jetting. Let's take a look at some of the applications. One example in this particular case is a mold that is used to generate prototype tooling with a limited number of parts that can be manufactured. Here is an example of a mold for injection molding for ABS that was used by Well from a Somos-based commercial resin provided by Stratasys. Another application provided by Envision Tech for a dental application involves making these color match crowns by changing the filler, changing the optical properties. Using reactive polymers as a binder for building sand molding. Molds for sand casting is an example over here. Those molds can then be used for casting metal components. This was provided by VoxelJet for an engine component for Porsche. Here's another example provided by X1 for one of its vendors that is based on furan resins. Again, this was a sand casting mold for a pump component. As we go to the second part of module 2, we will see that there is a lot of careful analysis of reactions and protocols for characterizing reactive polymers, especially using SU8 as one of the types of epoxies for photolithography applications. This provides an important avenue for being able to create much smaller features. You can see that these pillars are roughly in the order of about 10 microns. So this goes away from sand casting, which makes a very large structure, to these types of micropillar arrays, which are really tiny features. And here is an opportunity to be able to create multi-scale architectures by using reactive polymer, which was something that was a limitation by going through thermoplastic materials. In summary, reactive polymers involve many chemistries and cross-linking mechanisms. Changing the cross-linking density affects properties that you get out of such materials. The key focus, of course, is how these kinds of reactive material can be processed by 3D printing in module 2, and the use of filled polymers to build complex systems and also systems with microscale features. Properties emerging from reactive polymers will be looked at in the next class.